So now we're going to start section 14.7, which is about triple integrals in other coordinates. So we're going to recall some things that we've previously talked about. So we talked about cylindrical coordinates. And remember, cylindrical coordinates are represented by an r, theta, and a z. And then we had some conversion equations. So this was x equals r cosine theta, y equals r sine theta, and then the z coordinate stays the same from rectangular to cylindrical. So remember, this is essentially polar, but in 3 dimensions. And so you can talk about a cylindrical block that's given by r is between two fixed values. Theta is also between two fixed values. And then z is between two fixed values. And so we can think of this in our 3-dimensional system, x, y, and z, as you go out a distance or an angle of theta 1, and you go out an angle theta 2, and then r is between, r represents the radius from the origin, right? So maybe this distance right here, this is r1, and then this longer distance maybe is r2. So the sector you're looking at is between here, 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 and here. And then you have a copy of that for all of your z values. So maybe z1 to z2, you get a cylinder here. So let me see if I can draw this. A block of a cylinder, essentially. There we go. So there's my chunk of a cylinder. You can also talk about general regions in cylindrical coordinates. So let's say I have a solid region Q, and you're going to consider the projection R onto the XY plane described in polar coordinates. So then you can define Q XYZ, where XY is in your region R, and then H1, and then Z has some bounds on it. But then you can describe the region R using polar coordinates r theta, where theta is between two fixed values, and then r is between two functions of theta. So then when we're looking at our triple integral over the region the solid region Q of our function f, you can think of it as being a double integral over the region R, and then the integral h1 of xy, h2 of xy, so you can think of it as this single integral and then a double integral. Or if we want, we can think in terms of cylindrical coordinates, this triple integral. It's the integral theta goes from theta 1 to theta 2. R goes between g1 theta, g2 theta, and then instead of having x and y, you replace x by r cosine theta, r sine theta. And then you're going to have to do the same thing in your function, replace x by r cosine theta, y by r sine theta, so you can stay the same. And remember, anytime we do things in polar coordinates, we get an r in our integral, an r. This is dz dr d theta. So this is how we can do a triple integral in cylindrical coordinates.